I'm going to try to describe to you what my research actually entails. I'm working for a department of archaeology, and as you know, whenever archaeologists excavate things, a common item that they find is bone. Bone survives diagenesis, which are processes that occur after death, much better than any other body tissues. Therefore, it's a material which quite a lot of research is carried out on. Currently, if you look at a piece of bone and you analyse its chemicals, you can find out whether people were vegetarians or carnivores, whether herbivores were grazers or browsers. You can determine whether people ate C3 or C4 plants, which means you can tell when people moved from a wheat to a maize agriculture, and it's astonishing the number of different uses this can be put to. I'm going to be analysing nitrogen, carbon and hydrogen in the bones, specifically in bone collagen, which is the protein which holds bone together. The other part of bone is mainly carbonaceous material. That's all the calcium and the mineral part, which provides the strength. We dissolve the mineral away and take the collagen, and then it gets run on an instrument called a mass spectrometer, and this burns the protein into its individual atoms, and we can analyse the atoms that we collect. Each atom has a different number of isotopes, which means that it will have different numbers of protons or neutrons in its nucleus, which means that it has a different number of neutrons in its nucleus, which give it a slightly different weight. Because the atom has a different weight, it will react differently in biochemical reactions, so something like evaporation, all the lighter isotopes would evaporate preferentially to the heavier isotopes. This enables us to look at the ratios of the different isotopes, and from that we can deduce what the original atoms actually came from. This is how we can tell whether somebody ate plants or animals, because plants and animals have a different basic ratio to themselves. One thing that we can't tell is when somebody ate freshwater fish. Now, because water has a lot of old carbon in it from things like rock on the beds of rivers, which dissolves into the water, it's very, very difficult to use radiocarbon dating to get an accurate date for the bones of a burial. By analysing the isotopic ratios of hydrogen in the bone collagen, we are hoping to be able to tell when somebody had a diet which included freshwater fish. If possible, we want to find out how much of their diet was made up of freshwater fish, and therefore we can have some idea of how many extra years may have been put on the radiocarbon date. At the moment, the research is in its very initial stages. We're currently trying to collect samples from a whole range of animals, and we'll be analysing the bone collagen of the animal bones to see whether there's any effect across trophic levels, i.e. if one animal eats another animal, how does the ratio change up into the animal that consumed the meat. All that the animals we analyse have generally been killed on the roads by traffic, or sometimes some of them have been poisoned in fields by rat bait or something like that. And museums act as quite a good store for animals like this that we can collect. Many people take in animals that they find to museums as they have taxidermy sections, and what the taxidermist doesn't want, people like myself collect to analyse. we're comparing two different ecosystems. We're comparing the terrestrial ecosystem, where we're using things like mice and voles, right up to birds of prey and foxes and other higher carnivores. And we'll compare the data that we get from those with organisms from a freshwater ecosystem. And there we'll be analysing types of fish and birds which eat fish, such as herons. It's a lot more difficult to get a good food web in the aquatic side, whereas terrestrial mammals very commonly studied, and there are therefore very many groups which already have collections of animals which can provide us with bones without us having to search too hard. From the carbon and nitrogen, we can tell when marine foods were eaten. Marine fish gives a very definite signal with the carbon isotope ratios, but unfortunately freshwater looks exactly the same as terrestrial food. So carbon and nitrogen are not actually being measured for the strict purpose of this research. Only the hydrogen will be of any use to us, if indeed it does tell us anything.